Gracias. Hola, me llamo Igor Sysoev, soy de Moscú, Rusia. Soy el creador de NGINx. Sé lo poco que puedo decir en español. Desde ahora voy a hablar en inglés. Well, first of all, I would like to speak about NGINx origins because they determined NGINx advanced features and limitations. In Russia, apart of vodka, bears and balalaikas, there's a lot of web search engines. The first one was Rambler. When I joined to Rambler in 2000, we used front-end and backend configurations typical for the time. Apache 1.3 with mod proxy and Apache with mod pair stay behind the first Apache. For images, Flash and other static files, we used a dedicated lightweight server such as Tiny, HTTP, Boa, and Masop. One day, one of our developers said me that he suspects that mod proxy doesn't really accelerate backend, and asked me to look this issue. I investigated this and found that mod proxy used just a small 8 kilobyte buffers, and all buffering was really done by kernel circuit buffers. Besides, mod proxy runs in some kind of half-duplex mode. When it reads synchronously response from the backend, it cannot send anything to a client. Mod proxy used very different API. It was not similar to other Apache models, so it was rather hack. So I decided to rewrite from scratch, and I created a new model, mod XL, that can really accelerate backend, can cache responses, and can send responses through chain of filters. In short, it was much better than mod proxy. However, there was one drawback: scalability. The scalability was limited by Apache architecture, one client connection per process. On the other hand, lightweight open source web servers at the time can only serve static files. They cannot proxy requests. Besides, the configuration capabilities was quite limited. So I decided to write a lightweight server with which will be handy configurable and can serve static files and proxy requests to remote servers. The first problem I have to investigate was C10K problem. C10K, that is how to handle 10,000 connections on a single server. The open source servers of the time used select and poll methods. They can handle about 100 connections. However, these methods wasn't scalable for 2,000 connections. In late 90s, internet grows dramatically, so all operating system developers developed different methods to get notification from kernels. They were dev poll method interface developed for Solaris, HPUX, and other commercial Unixes. KQ interface developed by FreeBSD team, and real-time signals developed by Linux developers. However, design of these signals was broken, and soon it was replaced by ePOL method. The design is not much better. People sometimes ask me why I didn't use libevent for this. The answer is simple. The investigation of this CTKN problem was the core of the project. I simply didn't want to use some library to resolve this issue. Besides, I did many experiments. A part of canonical non-blocking Unix operations, I investigated asynchronous I/O read and I/O write. And for FreeBSD, I developed my own ellipse thread library because FreeBSD 4 lacked thread userland support on the top of kernel threads. I'm a big fan of portability, so I like different hardware platforms, different operating systems. I like diversity. I like to investigate the common features of these systems and curious differences. So I wanted NGINx to be portable as Apache. Apache has various ports to exotic or now dead operating systems such as IBM OS2, Novel Network, BIOS, etc. Fortunately, I stopped at the right time. Nevertheless, Windows port was developed from the very start. Now I believe it was a mistake. Nevertheless, NGINx can run on the most modern Unix flavors and on the many hardware platforms. For portability, I didn't use Auto Tools because it's rather a monster, and I wrote everything, configurations, scripts by hand in shell, and it actually is not hard work. At that time, dual processor systems began to be widespread, so NGINx certainly should run on SMP systems using either several threads or several processors. Finally, the later case was chosen. This is a scheme how NGINx, scheme of NGINx processes. The master process read configurations, test it, and then run worker processes. All client connections are processed only inside this worker thread. The master process usually run under super privileged user, while worker processes run under non-privileged users. If worker will exit abnormally, a master process will start a new worker to replace the failed one. If you want to reconfigure NGINx reload its configuration, you just send a hub signal to master process. It will read configuration, test it, and everything is okay, it will run worker processes. After this, it will send a message to the all work processes to shutting down. These processes will close all keep alive connections and will continue to proceed existing connections until they will be closed by client or by the service itself by timeout. Besides worker process, there is also two helper cache processes, cache manager and cache loaders. NGINx stores cached response in simple files in usual directory hierarchy. Between all processes, there is a shared memory and metadata of the all cache data is stored in this memory. The shared memory used for three reasons. The first one, to discard requests that wasn't requested for a long time. It's simple, least recently used queue. The second reason is to keep entire cache size in specified limits. And the third reason is the following. When worker processes need to find a cached response, they look in this shared memory for metadata. If the metadata was not found, the request is passed to backend. However, at the start of the server, the metadata are not present in memory. So workers have to look up on the disk to check if the response is present on the disk. In parallel, cache loader runs and load all metadata of the whole cache inside this shared memory. After cache loader will exit, all requests, all workers will never test cache response on disk. Each worker is single-threaded. It uses epoll, KQ, and other interfaces to handle 1,000 clients connections. The request processing model is inspired by Apache. NGINx runs requests through several phases, finding appropriate locations, URI rewriting, access control, etc. Finally, a request is handled by some content handler. It may be static file handler, proxy handler, fastgi, and others. The response, content handler creates the response, and then the response passes through output filter chain. It may be zip, filter, SSI, XSLT, and many others. Since NGINx was intended to use in heavy loaded environment, this determined its features. First, NGINx should be a backend accelerator. For example, NGINx buffer completely client upload and then send it back to the backend. It's a desirable feature of accelerator because in this case we minimize time of interaction between client and backend. However, now people use NGINx as load balancer for many backends, and they prefer to use non-buffering uploads to, for example, to show upload progress bar. Currently, NGINx doesn't support this feature. The next feature defined by heavy load environment is reloading whole configurations, even if you need to change configurations of some server. It is not a problem for heavy load environment because this is not often the case. But if you run shared hostings and you have 1,000 hosts, 1,000 servers, you will do, and they reconfigure it very often. You have this will cause a lot of worker processes, old worker processes shutting down. For the same reason, heavy load environment, NGINx has no support CGI, because CGI is not compatible with heavy load environment. For a long time, there was no runtime host resolving in NGINx, because it is not very required operations in heavy load environments. Well, a part of heavy loaded features, NGINx should have other features associated with Apache annoying drawbacks. I never liked Apache configurations due to its complexity. When the configurations applied for request is a mix of global and virtual server locations, directories, files given by static prefixes or regular expressions. This flexibility allows to create small configurations for small size. But when the size features grows, and maintenance costs grows exponentially. So NGINx use simple configurations. All configurations is limited by location. And the complete configuration should be specified in isolated locations. Of course, this can lead to duplicating some parts of configurations inside locations, but if you need to change something, you can use find and replace in your favorite editor, and it will take a minute. If you in Apache configurations or in poor written NGINx configurations with regular expressions, you have to look through the all configurations carefully to find all hidden dependencies. It may takes hours, and even after this, it doesn't guarantee error-free configurations. I personally maintained configurations with 100 locations without any issues. It would not be possible if locations was specified using regular expression or in Apache configurations. The next thing I never liked in Apache is log rotations. At job, we usually rotate logs at midnight. And there were several times when hosts lost network connectivity at this time. Apache could not resolve some hosting configurations and exit abnormally. Operator on duty calls me, I wake it up and hate this. So I wanted to resolve this in two ways, and I want to resolve this and done it in two ways. The first one, to rotate logs, you just do not need to reload configurations. You need only send user one signal to master process. It will reopen log files, change permissions to allow worker processes to open them too, and send a message to worker process to reload these files. And the second way was a configuration configurations process is more reliable, as if NGINx, when NGINx received a hub signal to reload configurations, it reads it, tests it, and if everything goes wrong, it just rolls back new configurations and run with previous one. No one calls me in the night, I sleep well, everybody's happy. And the final, my favorite thing in NGINx is online upgrade without downtime. I personally always use it. So, after 2 years of development, on October 4th, 2004, version 0.10 has been released. By the way, today is 9th anniversary of this public release. The first release can serve static files, proxy request to remote host, and support SSL using OpenSL library. That day was not accidental. It was 47th anniversary of launch of the first artificial satellite, Soviet Sputnik. In January 2005, FastCGI support has been added. FastCGI protocol was developed in 1990s, but it wasn't widespread until the 2000s. People prefer to use mod PHP or mod Perl embedded inside Apache. A second rebirth of this protocol is associated with Lite server, then with NGINx. These web servers cannot run PHP inside worker processes, so they have to use some external process to run PHP. And FastCGI was a quite natural solution for this. In spring 2005, server-side includes was added to NGINx. The main, it wasn't complete set of SSI directives, but some limited set. The main feature of SSI implementation in NGINx was NGINx is able to run several can run several includes in parallel from a remote host. It's very useful for binary system if you have on one page several inclusions from different binary systems. They will run much quickly compared to the case when you run them one by one. In 2006, I experimented with embedding Perl inside NGINx without great success. And 2008, a lightweight NGINx observer have got two very heavy filters, XSLT and image filters. In 2009, cache was finally implemented, and support of disk asynchronous I/O has been added to NGINx. And on April 12th in 2011, version 1 was finally released. This was not accidental day 2. It was 40th anniversary of first flight, space flight, first human space flight in history, Yuri Gagarin's flight. In summer of the same year, we incorporated NGINx company, and the company had received 3 million venture funding. We continue open source development. We improve our English documentations because its quality was very poor. We offer commercial services, professional services, and recently we have released our first commercial product, NGINx Plus. In spring 2030, we have added WebSocket proxy support and SPDI protocol support. Currently I'm working on the next NGINx version. There are many differences in architecture between version 1 and version 2, based on my own development experience and people use cases. The main difference is asynchronous approach versus non-blocking approach. Version 1 uses non-blocking I/O. Usually people use these terms interchangeably, but there is a subtle difference between them. Non-blocking I/O returns status immediately. It may be complete operations, partial operations, not available at the moment, or fail. Asynchronous I/O, the status of asynchronous I/O is not known at return of the function. I/O just start operations, and when it will be complete, for example, completion handler can be called. Why I chose asynchronous approach? Non-blocking approach is easy and is suitable for simple applications. However, if you try to use it in complex applications with long filter chain, the things become more and more complicated. Asynchronous mode is more complex than non-blocking, but for complex applications is more suitable. Of course, using I/O asynchronous approach doesn't mean that I use I/O read and I/O write operations. These operations are broken and non-scalable, so I emulated asynchronous operations using Unix canonical non-blocking operations. Asynchronous approach incites to use queues, and queues in turn incite queues batching of operations. NGINx can batch the single system calls. In future, this way allows to give dramatical improvement when syscall code will fit inside CPU L1 instruction cache. However, currently the cache size is not enough, according to our investigations with Intel performance unit statistics. The next difference between version 1 and version 2 is interface notification utility interface. Version 1 interface was influenced by KQ. KQ is more sophisticated interface, and if we compare it with ePOL and other interfaces, it's more complex, more handy. Version 2 is more suitable for the simpler interfaces such as ePOL and others. And finally, the final difference between version 1 and version 2 is multi-threading. If we look at processes in version 1, all processes are single-threaded. For version 2, if you look at process of version 2, the picture will be the same, except that worker processes are multi-threaded. Worker processes use auxiliary threads pools. When worker of version 1 need to read data from disk, it may block for several milliseconds, and for this time all client connections are stalled. To resolve this issue, auxiliary thread pools was introduced in version 1. When worker thread need to execute some potential blocking operations such as open file, getting its attributes, reading files, read ahead file, it passes this job to auxiliary thread pool. After these operations will complete, auxiliary thread send the state of the operations back to worker thread. Worker thread can run several worker threads. So a worker process can run several worker threads. Each such thread has its own ePOL or KQ notification facility, and connections never migrate between these worker threads. The connections can be passed to auxiliary thread, but auxiliary threads will return the connection to the same worker thread who initiated this task. And finally, dynamic future. Almost all NGINx directive supports variables. Virtual servers can be reloaded separately if you need it. NGINx version 2 support dynamically loadable modules. And the finally feature, NGINx version 2 can work with more SSL TLS libraries. In addition to OpenSSL, it supports also GNU TLS, CASL, and will support Polar SSL too, and probably other libraries. All these libraries can work simultaneously inside the worker process. It was not intentional solutions. I simply need to compile them together for testing, debugging, and finally decided why not allow to run them simultaneously. For example, you can use OpenSet for one listening port, GNU-TLS for the second listening port, and connect to some upstream using CVSL. That's all. Preguntas?